This is paper 2, video 10 for the February mock. This video is all about composite functions and drawing functions. So here we've got that g of x, this function, is the square root of x. The question wants us to draw the graph for the inverse function of this. So in other words, y equals g to the minus 1 of x. It wants us to do that for the values minus 3 up to 3. Well, g to the minus 1 simply means the inverse, the opposite. The inverse of the square root of x is x squared. So in fact, all this question is asking us to do is to draw the graph y equals x squared for the values minus 3 to 3. So if it had said cube root of x, we'd have drawn the graph x cubed, and so on. So g to the minus 1 of x, just what is the opposite of that? So y equals x squared, if we did a quick little table of values, for the values of x going from minus 3 up to 3, we will then be able to very quickly plot and draw this graph. Minus 3, because all we're doing is squaring it, minus 3 squared is 9. Minus 2 squared is 4. Remember, you've got a calculator if you wanted to do it for you. Minus 1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. And 3 squared is 9. We then just need to plot each of these coordinates onto this set of axes that I've drawn ready for the question. And plotting every single one will give us something that looks like this, which we can then join with a nice smooth curve therefore forming the graph y equals x squared, which is simply the inverse of the square root of x. The next question is similar, but this time we're looking at a composite function. So we've got f of x is cos x, g of x is representing the function x plus 90. Before we draw anything, we need to consider that we are going to do y equals f of g of x. Now f of g of x simply means that I am substituting x plus 90 into cos x. So I'm simply going to replace this letter x here with x plus 90. So all that means for f of g of x is I replace the x in the equation at the top with all of this. So that gives me cos of x plus 90. Now again, just like the last question, all that means I need to do is substitute in a few different values to try and see what this graph looks like. Now I've pre-drawn these axes here because whenever we're drawing trig graphs, we always have set points at 0, 90, 180, 270 and 360. Basically quarter of the circle each time. So all I'm going to do is substitute in these values to see what it gives me on the graph. So cos of, to start off with, 0, so cos of 0 plus 90. If you type that into your calculator, that simply comes out as nothing. So that would be plotting a point just there. If I then do substituting 90 into this little function, that would mean that I need to do cos of 90 plus 90, just replacing the x with 90. So that's the same as cos of 180. Cos of 180 gives us minus 1. So remember, it was 90 that I substituted in, so 90, I'm going to put a little dot at minus 1. I'm going to do the same then, cos, if I substitute 180 in this time, so 180 plus 90, which is just the same as cos of 270. Cos of 270 gives us 0, putting it into a calculator. So when I've used the number 180, the value of this is 0, so just there. Two final ones I'm going to do. cos of 270 plus 90 is the same as cos of 360. Typing it into your calculator, it gives us 1. So if when we substitute 270, give us a value of 1. This is starting to look a little bit familiar to maybe some of the trig graphs you've seen. Final one, cos of 360 plus 90. Again, type it into your calculator and it comes out as 0. So it stops just there. You then just need a nice smooth curve going through all these points, looking quite like the sin and the cos graph that you may have seen in other parts of the course. So looking something a bit like that.